Welcome to This Explainer. Today, we're diving into what is arguably the most absolutely fascinating frontier in science right now, the human brain. The way we understand human physiology, and specifically how we actually learn, is literally shifting in real time. So, if you're wondering how to adapt, or honestly, what makes you, well, you're in the exact right place. We're going to walk through how your everyday behaviors are literally reshaping your mind. Okay, let's dive into this. It all really begins with the deceivingly simple question, one that strikes right at the core of human nature. How do we actually learn? I mean, really think about it for a second. Every single skill you possess, every random memory you hold on to, every fact you can easily recall, how did it actually get locked in there? And right on top of that, we have to ask a second question. This one creates a real compelling mystery. Why do some of us learn things so much more easily than others? Why is it that some kids just thrive in traditional schools while others really struggle? Or, why can your friend just pick up a new language in a few months while you've been battling with it for years? Well, to solve this mystery, we first got to clear away some old baggage. See, for a very, very long time, science just had it wrong. There was this massive misconception out there that after childhood, or, right around puberty, the brain essentially just locked into place. The old belief was that from that point onward, the brain couldn't really change at all, and any changes that did happen were strictly negative, like just slowly losing brain cells as you age. But thanks to some absolutely incredible advances in modern MRI technology, we now have physical proof that this is completely 100% false. Your brain is not some static block of concrete. It's a constantly shifting landscape. In fact, every single day, millions of neural connections in your head are actively being pruned or strengthened. And hey, there's another major myth we need to bust right here. The idea that we only use a tiny fraction of our brain, and that when you're just sitting there doing nothing, your brain is totally silent. No way. Totally untrue. Modern imaging shows us that even when you are completely at rest, just staring blankly out a window, your brain is highly active. It's literally humming with electricity and chemical signals. So, the absolutely crucial point is this. Your brain is incredibly dynamic, and the mechanism behind all of this is called neuroplasticity. This is simply the brain's ability to constantly reorganize itself. Literally every single time you learn a new fact or practice a new skill, you are physically altering your brain. And honestly, the best news, this happens regardless of your age. Your daily behaviors are physically changing your brain all the time. How amazing is that? So what does this neuroplasticity actually look like under the hood? Well, your brain adapts to support learning in three distinct, basic ways. You can kind of think of this as the rule of three for brain change. First, we have chemical changes. Second, structural changes. And third, functional changes. And most of the time, these three are working together in this beautiful concert to help you acquire new abilities.
And this brilliantly illustrates the difference between those first two. Let's say you're trying to learn how to juggle. During your first practice session, you start getting the hang of it, right? You feel like, hey, I've got it. That rapid improvement is all thanks to chemical changes. Your brain quickly increases the concentration of chemical signals bouncing between neurons. It's super fast, but it only supports short-term memory. Then you wake up the next day, you try to juggle again, and bam, you're dropping balls everywhere. Why? Well, because you lost those short-term chemical boosts, and you haven't actually built the structural changes yet, the physical alterations in the connections between your neurons that are actually required for long-term memory. Long-term memory takes physical construction and, well, that just takes time.
Sustained behavior physically enlarges targeted regions of your brain. It's just absolutely fascinating. To put that into perspective, look at people who read Braille. They literally have physically larger hand sensory areas in their brains compared to the rest of us. Or if you're right-handed, the motor region on the left side of your brain, which is the side that controls your right hand, is measurably larger. And famously, London taxi drivers. They have to memorize these incredibly complex city maps to get their licenses. And because of that, they have measurably larger brain regions devoted to spatial mapping. It's true, you literally build the brain you use. Okay, moving to the final part of our rule of three, functional change. As you use a specific brain region over and over again, it actually becomes more excitable and way easier to activate. Eventually, your brain dynamically shifts how and when entire networks are activated based on what you use the absolute most. So whole networks physically shift and change just to make your most common everyday tasks feel completely effortless. But all of this brings us to a very serious, really high-stakes question.
If our brains are just so awesomely plastic and capable of all this incredible change, why do we ever fail? Why do we forget things as we age? And crucially, why is it so incredibly hard to recover from brain damage, like a stroke? Stroke is actually the fourth leading cause of death and the primary cause of long-term disability in adults worldwide. If neuroplasticity is so great, why can't it just easily fix that? The answer lies in the absolute scientific bottom line. The primary driver of neuroplastic change in your brain is your behavior. I hate to break it to you, but there is no magic neuroplasticity pill you can just swallow to suddenly learn French or fully recover from a stroke. To make those actual structural long-term changes in the brain, it requires incredibly large, frankly difficult doses of practice. You simply have to put in the behavioral work. But actually, here is where it gets incredibly empowering. Research shows that increased struggle and difficulty during practice actually lead to greater structural change in the brain. So when you're super frustrated, when a task feels just slightly out of your reach and you really have to hunker down, focus, and fight for it, that is exactly when your brain is physically remodeling itself the most. Struggle isn't a sign of failure. Struggle is literally the physical sensation of your brain building new structures. However, we definitely have to include a vital warning right here. Neuroplasticity is a two-way street. Because your brain is constantly shaped by your behaviors, it can absolutely be shaped negatively too. Just forgetting a skill because you stopped practicing, that's neuroplasticity. Addiction, that is a form of neuroplasticity. Even chronic pain involves the brain becoming structurally and functionally hyper-efficient at feeling pain. The takeaway is that your brain is shaped by everything you do and, crucially, by everything you don't do. Now, what's really interesting about this slide is this specific number, 10,000. We've all heard author Malcolm Gladwell's famous 10,000-hour rule, right? It's that idea that to master literally any new skill, you just need to put in 10,000 hours of practice, and boom, you're an expert. Well, talk to any brain researcher, and they will quickly tell you it is just not quite that simple. The actual truth is, there is absolutely no one-size-fits-all recipe for learning. Because every single brain is physically, uniquely shaped by its owner's past behaviors, the amount of practice required to learn something new has incredibly high variability from person to person. For some people, mastering a particular skill might take way more than 10,000 hours. For others, depending on their brain's pre-existing structures, it might take far less. It's just totally unique to you. And this realization of incredible individual variability is really paving the way for the future, which is personalized learning. Think of it kind of like personalized cancer medicine, where specific genetic markers dictate the best chemotherapy. Well, in stroke recovery and education, scientists are now looking at biomarkers. These are specific, measurable characteristics of an individual's brain structure and function. By mapping out these biomarkers, we can actually match an individual with a specific teaching method or rehab intervention that their unique brain will respond to best. And what's wild is this variability doesn't just exist between you and your neighbor, it exists entirely within your own individual brain. For example, you might have networks that are highly optimized for auditory processing, which means learning to play the piano feels incredibly natural and easy to you. But on the flip side, your spatial mapping and motor networks might be way less developed, making learning to snowboard an immense, highly frustrating struggle. You are fundamentally unique, not just compared to other people, but across the different skills you attempt yourself. So how do we actually take all this fascinating science and apply it to our lives? Well, you have to actively harness your own neuroplasticity. It really starts by paying attention and studying how you learn best, because as we've seen, your brain is entirely unique. Then you need to intentionally repeat the behaviors that are healthy and productive to build up that structural memory. At the exact same time, consciously break the habits that are wiring your brain in negative ways. But above all else, you just have to do the work. Remember, the struggle you feel today is literally the physical construction of your future abilities. I really want to leave you with this powerful instruction from Dr. Boyd. Go out and build the brain you want. Everything you encounter, everything you practice, and everything you struggle with is literally physically altering the landscape of your mind. You are the architect here. So as we wrap up this explainer and you go about the rest of your day, I want you to ask yourself a very serious question. What kind of brain are your habits wiring right now?